It's my great pleasure to introduce the keynote speaker of today, Prof. Lukas Snyman. I just want to give you a very brief synopsis of what he's about. He's currently the director of the School of Engineering at UNISA, which forms part of the College for Science, Engineering and Technology, or CSET as we know it, at the Florida Science Campus in Johannesburg. Again, some of you are too young to remember, but it used to be the Technikon of South Africa, the kind campus where we are now. Now, he serves in the deanery of the college and also on the Senate of UNISA. For 27, he's also the designated chair of the Engineering Council of South Africa, Africa Exa Dienstforum. Now, we come to the important part. What is his expertise? It's in the field of semiconductor physics, device physics, analog and digital electronics, and there's a lot of tronics that I cannot even pronounce. He researched it. Now, his high-end research focuses on systems and electronic manufacturing technology. And again, this, you can read it for yourself. There is, the field of research is very, very wide. But he also has a group that he's part of, and the group focuses on the development of applied innovative electronic systems and products that have a market potential in South Africa and Africa. And he will talk to some of these things that they've developed today. Those of you that was fortunate enough to find one of those technology booklets from UNISA in your welcoming pack, I think there's 4. Of his products that is discussed there. Now, what he's done can be applied to our domestic household. And it is the so-called thermal to electricity converter system that converts heat to electricity on a continuous basis at 10% efficiency and innovative low-cost and turbine system. Lukas has published approximately 100 research outputs, that's patents, conference articles, journal articles, and etc., mostly at an international level. He's currently the main inventor and co-inventor of 6 granted US patents, 4 granted European patents, 1 Korean patent, 2 Chinese patents, and about 10 SA granted patents, and there's 4 more in the pipeline. In 2015 and 17, he was designated as a finalist by the National Science and Technology Forum, NSTF, in the categories Photonics and Innovation and Applied Technology. In 2010, he was designated as Innovator of the Year at the Tshwane University of Technology. He is currently a regular reviewer for several journals in the US, and he has collaboration with international universities in the UK, Europe, and China. And is a research associate at the SAIIE Technical University in Paris, France. Please welcome Prof. Snyman. Thank you.
It's a privilege for me to see such quite a wide audience here today. I hope that you will all have a very good day and that you are in a good mood today. Okay? I think most of you are having a day away from work, so I think we have some things to celebrate, eh? And most of all, I hope that you will find our presentation entertaining, okay? As you've heard, I've been a guy that has moved around quite a lot and did a lot of things and still trying to do a lot of things. I'm just that kind of person. Especially one of the things that stimulates me most is innovation, to create something new, to apply technology, but also to create technology. And I hope that some of these things will come over. Especially lately, we had a drive to look at transfer of technology. So let me start maybe on a little bit of a negative note, okay? And then I'll try and be more positive towards the end, okay? I'm going to use the laser pointer, so I will try and switch between the screens. So if we look at our South African situation, 30 to 35% of people under 35 are unemployed. Last year we had that Fees Must Fall campaign, with students demanding free education. So the youth is not satisfied. We have budget cuts all over, especially hitting the universities. And then generally, what concerns me most is that there is quite a lack of entrepreneurship in this country. If 35% of the youth is unemployed, the economy is already active, the free market system is already active. It means we have to try and do something new. And one of the things that we should do is to embark into entrepreneurship, because that is the only thing that can create jobs. And what are we doing about that? Can we not do much more? And where should it start? Or who can make a contribution? And lately I thought, actually the last 3 years, I thought that, wow, universities can make a contribution. And I will try and show you a few progresses today. I also serve on the Dean's Forum of the Engineering Council. The deans get together about 4 times a year. They discuss common things, common problems. The interface with the Engineering Council and also the institutes in South Africa, the interface with the governmental department, interface with industry, and they try and do proactive projects. So, and during our last meeting, we made a quick survey. What does the deans tell us about the university? What is the state of university? And I was quite surprised, or well, to hear all the negative comments. Universities is suffering from critical staff shortages, lack of resources, funding is poor, salaries is poor, lack of industry interaction, lack of government interaction. I can tell you many stories about that, right? Lack of transfer, as I said, entrepreneurship can be done much better. And we also have a shortage of engineers in this country. So that is the message that we get from the deans in South African engineering faculties. The question is, what are we doing about it? What stewardship opportunities can it bring to us, especially with this conference? So I want to start to talk a little bit about the College of Science, Engineering, Technology at UNISA. Briefly, this is our campus in Florida, south of Johannesburg, and the government has invested into this. It's it emerged from the old Technical in South Africa and became a new College of Science, Engineering, Technology. It's very well situated. It's in an upmarket area. And the government, it's near the big Soweto areas and the southern areas, metropolitan areas. So the government has invested, I think, about 500 million, if it's not more, into this over the last 10 years. New buildings, laboratories, equipment, staff expansion. So there's a new kind of animal emerging there at the south of Johannesburg. So we have, just in the School of Engineering, and there are a number of schools there. We have the IT school, School of Engineering, School of Science. And I think these three schools actually make a good combination. Just in engineering, we have about 130 plus staff. We have 20 professors, and we're still expanding. We have about 70 lecturers, Some of them, big component is contractors, because we teach all over the country with online teaching. And we also have a lot of support staff for the laboratories. And we teach now all 6 engineering disciplines, diploma, BTech, and then also the B Engineering Technology Honours, and we have the Masters, also the Doctorate. Okay, so what is our niche? You know, I've been teaching at about 4, UNISA is my 5th university, and I've teach for big classes, you know, sitting with 300, 400 guys in an auditorium. And you spend 3 days a week on that. And then after the semester, the pass rate is still 35% or 40%. So I came to the conclusion that, you know, contact teaching is also not the answer. I think the problems in South Africa demands more. And therefore, even at previous universities, we started initiatives with online tuition. The guys from University of Pretoria, I was one of the first guys starting online teaching at University of Pretoria in the 90s. Okay. And today, University of Pretoria is one of the leaders with online teaching of the contact universities. So at UNISA, we just specialize in that, online teaching and engineering. And whereas other guys are spending a lot of time on lecturing, we spend a lot of time on developing modules. Because my experience has learned me, the better your teaching module, your book, your guide, your management system, the better student you become. Okay, so we spend a lot of that, and we still are busy with lots of new initiatives. What we developed so-called digital interactive teaching and learning modules. With a guy, it's all digital software package. Guy starts at some end, and then he works through a few chapters or modules. He goes to self-evaluation test, and that reroutes him according to his outcomes in the test. It's all software-based, and he gets rerouted depending on the outcome of the test, and that module will address his shortcomings and bring him back, route him back to the main route, and eventually we find that wow, the outcomes is extremely positive. Obviously, it takes a lot of energy to develop these modules, but this is some of the things we are busy with. Then, of course, you know that the whole world is moving to online teaching. If you look at UK and US, all the efforts there, and so there's so much open resource material already available on the internet, and we try and utilize this, and we guide our students. Our lecturers just make a survey of what is available, and then we try and guide our students to use the best open resource material. Practicals, obviously this is a challenge for us, but we have the laboratories in Florida, and then the students come in for block courses 2 or 3 times a year for a few weeks, and they do the practicals there. Some of it they can actually do it at work, at home as well, or in the workplace. We distribute some kits, you know, electronic kits. You can learn yourself on electronic kits quite a lot these days. Then we have an extensive working credit learning program. We have the project-based learning at the graduate level, which I think you're acquainted with. So we have that. And then we also, as I said, we have a very strong research group of professors working in directions that we try and publish a lot and interact internationally. And lately also we have this new thing, entrepreneurship outreach. If you quickly look at our statistics, our registrations are increasing. That's a diploma, this is the BTech, about 5,000 diploma students online teaching, 3,000 bachelors online, and that's also the masters. Very interesting lately, we have good successes with our teaching, and in the last 5 years, our graduations are increasing from 300 to 500 for the BTech, which is good news, okay? Our research is really increasing, our rated researches are increasing, our articles are increasing, especially this green curve is very promising. In the last 5 years, our articles in accredited journals has really skyrocketed. So you can see that hopefully the investment of government at UNISA is paying off a little bit. Okay, so we are thinking about new models, as I said, enhancing entrepreneurship and trying to increase collaboration with university, industry, and communities. Traditionally, universities have been operating like this. You have a few professors doing research, publishing papers, flying the world. Then you have many guys just doing industrial project work and engineering project work, and then other guys are teaching. They do a lot of teaching and hopefully also community engagement. So traditionally, this is the activities of the normal contact universities. And what are we trying to do different? We said that, wow, if we want to make a difference to the country, the needs of the country, then I don't think research will bring us very far, okay? Teaching, yes, if we can improve the success rates. But definitely what could make a big difference, if we at the graduate level and even at the work integrated level, if we could expand our activities there, and we could collaborate more with industry and form partnerships, okay, on the one hand. On the other hand, if we could accommodate more students on the campus and not doing master's project and doctorate projects, but just doing basic projects at the diploma, work integrated learning level, and at the BTech or the B engineering project level. If you could just focus on that, I believe it could make a big difference. And on the one hand, collaborate with industry. We have about 300 students, 500 world students in industry, about 300 students, BTech students in industry. And then if we could expand that and even populate more students on the campus, in the labs, using the facilities, working under supervision of the professors, we believe that could also make a big contribution with regard to entrepreneurship. So the two things: form partnerships with the industry, but also on campus, stimulate project work, create entrepreneurship, spin-off activities. So this is what we've been trying to do the last 3 or 4 years. On the high-end research, we are not doing too bad. We have a number of international partnerships, and we're exploiting all the benefits there, sharing of expertise, student exchange, postdoc, and already we have some investments coming our way. Just this year, we've managed a very big grant, Erasmus Mundi grant, of about 10 universities, with about 1 million rand just coming to UNISA. And this is a good example where the high-end research pays off and brings some investment at the universities. We have a large number of international collaborations. Our dean is very driving us hard on this issue. So France, Netherlands, China, the Erasmus Mundi, India, BRICS, and it's quite promising to see all the activities at that level. Just to show you one example, unfortunately it's my own. I work in the field of silicon photonics, And it started actually at the University of Victoria. We made a big invention that if on the normal silicon chip, if you design a device there and you know something about physics and you work there, it's silicon. You can actually generate light there from the silicon. The efficiency was very low when we started, but we said, wow, you know, this is something new. And we immediately started to patent, and now we have already 6 granted USA patents on this technology. And we managed to increase the emission intensity of the light about, I would say, almost 500 times, just from basic research. Lately, we are making a little light source on the chip, and then we make a waveguide, okay, optical fiber on the chip, and then we put a detector there, and some of my students, and we were working with France on this, when we modulate this light source, and it can modulate into the gigahertz range, we could transmit the optical pulses, signals, to the detectors, and there you can see the detection circuitry. And if you look on Google Scholar, you'll see that we are publishing quite a lot, my students and myself, in this area. Now we have collaborations with Netherlands, France, and China. So you should give me a hand. Hey. It just shows you what South Africans can do, right? So I think we should stop being pessimistic and say we cannot do it. We can, and we can make international contributions. There is the light source, and there's the detector. And as I said, we have at the moment 6 granted USA patents. Our challenge is to market this technology and to form partnerships. Maybe in this audience, some people are sitting in that like venture capitalists and have money to venture on. There it is. We are the professors. We make the developments. We don't have the time to really to transfer the technology and to take it into industry. That's one of the things that frustrates me most. You know, we do these beautiful projects in universities with the engineering final year project students and the BTech students. What happens? There's a report ending on a shelf, right? Doesn't go any further, right? And that is disappointing. So to come back to our model, we can merge the new technologies. Obviously, any new technology can find new applications. So those new technology can migrate into this lower level, project level applications. And even if we should constantly look at the needs of society and also try and integrate it there. Okay, so I've already talked about integrating the high-end research with the lower level projects. What we're doing now at UNISA is to actually establish dedicated management structures. Normally, universities have management structures for undergraduate and for the postgraduate. We want to create a new management structure focusing on this new concept of enhancing entrepreneurship, technology transfer, innovation. We want to put in place a whole new management structure there. And that's why I'm talking here today, because for that we need money. We need to talk to industry, and we need to talk to the government, okay? Because from government, money is scarce, but we need to be creative. And if we could pump in some monies here, like from municipalities, I'm sure that we can create this new idea of innovation and technology transfer. Now, if you start delving deeper into the possibilities are actually amazing. Obviously, a good option is to look at companies in industry that has already a manufacturing plant, a manufacturing line, already well established, maybe have some capital reserves already. Obviously, those would be good partners to join up with a school like UNISA and to look what maybe some of these technologies can augment the existing technologies at your company. That's one option. The other option is to look for venture capital and to use some of these new prototypes, new products, create SMEs, but for that you need venture capital and money again. So this one looks to me a very promising one. On the other hand, we sit with communities and municipalities with great needs in terms of capacity and expertise. Why can we not start talking to municipalities and maybe create some large-scale entrepreneurial projects? Mass entrepreneurship. You know, a lot of community guys working on simple, low-level technology, but at least you create jobs. And hopefully you can compete internationally with that. So that's another very interesting possibility. Now, if you start thinking further, the possibilities are enormous. Just in the Florida area, if we could, Florida is surrounded with lots of, I won't say low-cost housing, but there are lots of houses around. Not too expensive. Maybe we could buy out a number of these houses and we can just do prototyping and project development and product development in these houses. The UNISA Business School is nearby. They could help with the business plan management. So you see the opportunities are endless. Then you can create all these enormous spin-offs. Students, when they come and work in laboratories or work on projects or innovation or entrepreneurship, they need places to stay. So you can create a complete new accommodation industry. You can also create a complete new transport industry, business. One of our big problems is to get students from all over South Africa to the Florida campus, even from the center of Johannesburg out to Florida. It's a problem. So there are enormous possibilities. Obviously, there are a few examples already in South Africa, and I can maybe mention them. Stellenbosch, University of Pretoria, Johannesburg are already have activities in this direction. But the point I want to make, I think we should think creatively and expand these to all universities or to much more universities. Okay, I quickly want to show you some of our progresses with regard to entrepreneurship. I call it UNISA Technology Transfer Projects. Okay, we decided to choose renewable energies just as one focus point. There are others as well, but we will talk about this today. And if you think about renewable energies, they say the next 20 years, this is going to be the biggest industry in South Africa, right? Because the opportunities are just enormous. Now, there are many models. These days we see the so-called big solar plants, the wind farms. But if you think about that, is that the best solution? Right? Because the energy still has to be transported. The infrastructure, the capital layers are enormous. So, if you look on the internet, in India and China, the way they go is to rather go for the end user market. Okay. And especially China, India and China is really going this way. That you have a small wind turbine serving a number of houses, one house or a number of houses, right? And you could even hide this a little bit so that it's not so prominent. Put it in a wind tunnel or whatever, a wind funnel. So wind turbines. Small wind turbines is a big, big thing for the future. Electric cars. They tell us that in 20 years' time, mostly all cars will be electrical cars, right? And where will you charge your car? It will be at home. Okay. Where will the energy come from? Energy will come from the line, through a DB box, then it will serve your appliances. And the new line of thinking is that we should develop a kind of what we call a DC grid. Why do you need an AC network to supply or to interconnect appliances or to drive appliances? The new buzzword is to develop DC grids, microgrids. And this can especially serve the whole of Africa, because many places in Africa don't have AC grid. Right. So there are enormous opportunity for the development in what we call DC microgrids. Okay, I think all of you are acquainted with photovoltaic energy. And then the whole new technology, somebody just talked about the fourth industrial revolution today, the Internet of Things, the cell phone will connect everything together. So in future, if you develop a smart box there, a controller or whatever, talking to your cell phone, you can actually manage the supply, and you can even sell your supply, right? You can sell your own electricity to the grid. You can optimally manage your energy. In other countries, they have the rated tariffs. Okay, at peak hours you pay more. So this technology, together with your cell phone, you could individually manage your energy consumption. You can make a small business out there. So we see quite a big future for this. An area that particularly sounds very promising to us is the whole issue of thermal energy collection. You know, South Africa has, apart from Arizona, we have the second highest instance of solar irradiation in the whole world. Second highest. Only Arizona has a higher irradiance per year. And what are we doing about this? If you think about enormous energy absorbed on our roofs, okay, if we could just design a simple absorber, black absorber with low-cost piping, and you can absorb that thermal energy, and you can put electronics to it, control equipment and sensors, and you can channel this. All our solar geysers these days are small little things, 1 square meter, 1.5 square meters, right? If we could make this larger, 10 times or 20 times larger, just think about the energy that you can harvest, the end user. And that you can store in your geyser, okay? And heat energy is about 60% of your electricity bill per month. So there are huge opportunities. And really, the technology is not high. It's about piping and cementing and putting things together, right? Here is just an example of using a piping structure to optimize. One of my master students is working on this. Just use piping, put it on the roof, and see how can you optimize the absorption. And there's a lot of physics in there, right? But we have fantastic results. Okay, lately we stumbled across a new idea. And that is that, wow, if you have thermal energy, you can store it. And if you can develop a device that can convert the electrical energy to electricity directly, just think about the possibilities. If you look at in the energy market, the highest cost factor is in the batteries, the storage. If you make your business plans, the highest cost factor is in the batteries, the storage. If we could make a device that can convert thermal energy through I call it a black box there, with lots of electronics in it, and you can store the heat even, and you can even recycle the heat, right? And you can get electricity from that. Just think about the possibilities. And we've done some business models. Okay, I don't want to talk too much about the technology, but using thermal energy, there's about 6 times more energy than solar cells. Solar cells only use the visible part. Here we use the full spectrum of the sun's energy. Okay. And you can build these type of things. This is just a very simplified example. And I'm not going to give you all the detail, right? But on the one hand, you have a hot side, a hot side. On the other side, a cool side. You have heat flowing, and then the electrons and stuff works there. And if you design, you know your semiconductor physics, you can actually tap off electricity. I have a few master students working on the modules. I call it an extractor module. We started with 0.5% efficiency, and now we're sitting at about 10%. A huge progress. And now it's competing with photovoltaic energy, right? Why import photovoltaic cells from China and Europe all over if we can implement this technology? I've made some business analysis that if you design these systems, we can put cost on market, energy on the market for about 30 cents per kilowatt hour, right? Using a combination of these things. And I have about 10 master students working on these things at the moment. And you will agree with me that all these things, it's not really, there's a high technology component, but most of it is low tech, right? Assembling, and you add electronics to it. And surely, this can create lots of jobs. If we take this to a community, like in Soweto, and we tell the guys, just put pipes together, right? Just cement pipes together, put it on the roof, right? Right, you create jobs, and you save energy. So, this is some of our results. We got, as I said, almost a very, very high increase, okay? Okay, on the control box side here, we've done a little bit of work. This was done at the TUT. What we did with our students, this was at the BTech students, we put a few floodlights there, we took about PV cells, then we had the battery, inverter system, and then we built this here, designed it. What is this? There is a bank of what I call electronic switches, right? MOSFETs, right? Not mechanical switching. It's electronic switches. And this interface with the normal DB box on certain lines, and then if you use sensors, and you build this little control box here, computer box, software box, manager, energy manager, this guy can control the flow into the different lines, because some of you will realize that it's not so easy, right? Because with a PV system, you cannot drive your geyser, right? But you can drive your TV in some systems. So you need to build in some intelligence here. But the beauty about this is that this IT box can give priority to solar energy. While if solar energy is not available, or wind energy, it uses the grid. So your intelligence is built into that little box there. And we have a working model, or we have all the blueprints. I think I've talked already on the cell. This is an example of the cell phone. There is the cell phone receiver, and this was a line of lights. And from the cell phone, we could individually switch on and off the lights there. Right, this was done at the TUT. Okay, it's a product, it's ready. We can commercialize it. We played around with photovoltaics, And we made a very interesting discovery. You know, photovoltaics that are put on the market are quite low-cost technology. One of the big problems is that you have a glass surface layer, and that reflects the sunlight at the angle. So just by building a little contraption here with sensors and a few motors, and if these panels can follow the sun, we could get 25% more energy out of the system. Okay? And the students did that. Very nice project for students. Okay, at UNISA, we have a waste-to-energy converter group, Professor Hildebrand. She has a team of about 70 people, 70 students, and about 10 staff working on this here. And what they do is they work on the whole thing, on the Fischer-Tropsch type of process, where if you can take organics and plastics and woods and all waste, and you put it in this reactor, and you put a few catalytic converters and stuff in there and electronics, you can actually convert the waste to energy. You can get hydrogen gas from there and all kinds of organic gases that is usable. So it's there. We already have a few partners, industrial partners, which is signing up here to transfer, to take this technology and to run with it. Okay? So what this group is doing, they've built this little system out there in a rural area, and then they use animal dung, and they control the processes, and they can generate gas to the local community, methane gas, and the stoves are run on it. And this is a working example. Okay, so these are some of the things, examples. There are some more that we are doing at UNISA, and I would say many of these are kind of commercially ready for entrepreneurs. Okay, I want to talk quickly about another initiative that we launched this year. In July, we said, wow, you know, the communities and the students are crying out there for jobs. So what we did is we advertised the winter school, and then we took, this was a complete new idea, right? So we advertised this, and we asked for volunteer professors and lecturers, the guys with the ideas, and then we also invited the postgraduate students. Okay, now these guys have the ideas, right? But professors likes to publish, you know, they don't have time to make things, right? So we said, okay, why don't we get guys from the TVET colleges? So we got about 10 students from the TVET colleges. Why? They like to make things. They can weld, they can do metal processing. And we've put all this together. And then we even went further, and we contacted our community outreach department at UNISA main campus, and they have contacts with the communities. And so we had eventually 30 unemployed members from the communities also joining this winter school. And for 4 or 5 weeks, we worked together. And the professors and the lecturers started on their ideas. They did their market analysis, business plans, and they kind of controlling the process. Obviously, the other guys also assisted. Some of the electronics things, we did the prototyping, and we also outsourced the manufacturing of that, okay, because normally electronics is the kind of heart of component. And there you can see some of the guys working, doing the metal processing, some of the guys doing the welding work, some of the guys doing the construction work, and then the assembling, and eventually we had about 2 free products. The one was a low-cost wind turbine, okay, and we actually wrote a patent on it, right? We couldn't believe it, right? And the patent was granted. Innovative blade design, low-cost technology, low-cost technology, and we did analysis, web analysis, market analysis. This thing, we could assemble for even less than 5,000 rand. And we cannot, even China, because China still has to pay transport costs and duty costs to sell it in South Africa. So it just shows you that we can create jobs, or sustainable jobs, in South Africa. Right, this is a tiltable photo cell, and this one we took into Africa, Congo, and the whole community was celebrating one whole weekend, because for the first time in their life, they had electricity in this household, right? Okay, we can put all this together even into rural Africa. We had awards. Our big challenge now is to assist these guys to create masters. And that is a pity, is that we can take the students to there, but now there's no support. Government doesn't want to give them money. They don't know how to write the business plan. They don't know how to, not even to the bank, to get monies. And it's such a great pity. So if you guys even could assist the existing guys, because they have their certificates, they just need assistance to take these products further. Okay, my last section I quickly want to talk about is the funding models. We come a long way with funding at universities, and I can tell you that the current NRF systems, and even the TIA and the DST system, it's not working. I won't give all the reasons, but it's a pity, it's not working. And the money is declining, okay? Even our funding models for publishing papers. These days we don't get money even to go to abroad even more, all right? It's just a sad story. Even our patent management, our IP management, is not a good story. And I already told you about it in the interior support. What works is that when we put out calls, like in UNISA, we have an internal call system. And you write a few pages, 2 or 3 pages, and you go there, you make a presentation, they give you R500,000 or R1 million, and there you go. That works. That works. I call it a call, tender, and block round. Even working with SAIIE, the French, the British, the BRICS, that works as well. Same concept. 5-page proposal, personal interaction, grant money. That works. But why can we not extend these models to our local industry? If some of you guys are interested to collaborate and to take some of these technologies, maybe you could make a small investment. I like the short-term, short-cycle investments, so the risk is not high. Short cycle, short-term funding, and you have a very close monitoring. Maybe that can work. Industry collaboration. Maybe if we talk to municipalities and the local government, maybe we could work on the same concept, and even try and utilize venture capitalists more efficient. That can work. So these, I think, are quantum leap things that we should work on as a broad community in South Africa. IP management, obviously, the university is investing quite a lot of money into all these things. So eventually, we would like some return back. And our IP, Intellectual Property Management Office, tells us they only look for about 5 to 10% return. So you can take the product, if there's a patent on it, we license it to you, and you sign a type of agreement or a contract, could be short-term, short cycle, and all that university, UNISA, requires is a 5 to 10% flow back on your net profit. And I don't think so. You can take 90% of the profits. Okay, the high technology, obviously, that's a little bit more complicated. Okay, and that has to be more securely managed. To end off, yes, I think that if we focus on entrepreneurship at universities, in future, it could make a big difference in this country. And the ways to do it is to use the existing National Research Foundation money, but I really think that government should make a better investment, and especially the local government and industries could all make investment directly to this level. And I think the results could be quite substantial. Just to finally end, we have a little booklet with 20 technologies. All these technologies I've showed you, but there are also other technologies, and it's in the booklet. So if you could look at that, and if you have opportunities, you could contact me or Professor Creer, and you can also contact our technology transfer office to form type of collaborations or partnership. Thank you very much. Right.
All that remains then is to thank Professor Snyman for his insightful talk and some oil to oil his cocks up in the brain to come up with more patents. This is just a very small token of our appreciation. Thank you.